Living Machine stands for a new way of thinking about both biology and technology. On the biological side, it means thinking more about how systems emerged in biology and what the basic control principles are, or the operating principles of these systems. For the technological side, it is how do we capture these principles and map them into technologies that can advance the human condition.
This year in Edinburgh, for the 5th edition of this great conference, we have created a community of scientists that are looking forward, applying natural principles to robotics, to materials, and to, as well, understanding who humans are.
This is the reason why we looked at a huge variety of different plants and tried to understand how movements, and especially how the, let me say, bending during the movement is brought about in plants. I think this conference is very interesting for me. There's a lot of topics which I'm interested in, and especially robotics and biohybrid materials and systems are interesting for me because they may offer a new field of application for our materials and structures.
Living Machine is a framework of doing several things at the same time. The first thing is to try to understand living system as deep as we can, from material to processes to how it works, and building new tools to do that. New tools coming from the engineering side. And at the same time, it is translating what we are learning from the living systems into innovative technology.
So what we were doing is we were actually virtually spraying the extract of spinach with ethanol on top of the layer, and then we were shining light.
Living Machines is actually a platform for interdisciplinary research. It's not only about mathematics, informatics, and biology, but it's the connections between all these disciplines. And I think that art as a human project relates and can fill the gap between them and make them really overlap and collaborate much better.
This is basically the summary of it and the essentials of this model based on the biology that we found, but also taking into account data from other groups, is that this action selection circuitry can carry out 3 core functions.
Human shape or human existence is very important to explain not only the human behaviors but also for other animals or very abstract concept.
Marty is a humanoid and comes from one of our startup companies from the centre, Robotical, and I'm loosely associated with it in a mentoring role. And this is a robot that's being targeted at the developer market and at people who want to learn to program, kids mainly, who've maybe got a Raspberry Pi and they want something more advanced to program.
I came here because I wanted to learn even more how we can actually learn from nature and the organisms that surround us in order to create new algorithms or improve the current algorithms we have, and how we can also maybe take inspiration for hardware and create new robots that can help the community.
This is a real ant route from the feeder to the nest. These are images taken along that route. This is a kind of reconstruction of what you could see from the ant's point of view, and this is something closer to ant-eye resolution.
This is the best collection of people who think like I do and like our group does, in terms of how robots should be made and how they should be controlled.
I build robots that are basically emulations of the nervous system, and I'm interested in understanding how the nervous system works, and by building these robots I can basically study how they operate in natural environments. I come to this conference because there's a lot of people trying to do the same thing and we can all learn from each other.
I've been working on bio-inspired robots as long as I've been in robotics, for over 25 years, and this conference is focused exactly on that topic. It's got its center of mass on bio-inspiration.
We would like to have a hand that if you move quickly will do a power grasp, and if you move slowly will do a pinch grasp. There are many good reasons for robots to be more similar to natural. They have to be more compliant, interact better with humans physically to help and assist.
This is a Miro robot. It's a robot that I've designed with a few other people. and it's a living machine. It's a biomimetic robot, and it's like an animal, but it's not like any one animal. We take features of different animals, but it doesn't just look animal-like, it also behaves in an animal-like way.
And this is called RoboKid, and it's a much simpler robot, and it's something we've been doing with the schools in Scotland, targeting school children around about ages of 8 or 9. And we have a fleet of these that we take into the classroom. The kids work in groups to assemble these, and we give them videos to support them in doing simple tasks, a little bit of programming and some simple activities.
Living Machines is a different kind of conference. It's small, but it goes right across lots of different areas of research, from engineering to science, even philosophy. And it's asking, what are we? Are we some kind of living machine?